session. Good morning, one and all. We are going to start lecture number 9. This is the concluding part of third topic from module 1. So third topic is vehicle starting system. We have seen what is a starting system. We have seen what is a starter, what does a starter do, what are different configurations, and what are different types of motors. That is DC motor. Mainly we have said that is the series type of DC motor that we can use for starting system in the starter. So whenever we are saying starter, actually it's a starter motor. It is controlled by, there are few switch, there is a solenoid. So current flowing through that solenoid coil actually will start the starter. And starter means it's a small motor, starter motor, and job of that starter motor is to give an initial kick to the engine. So the starter motor is actually connected to the flywheel of the engine, and that flywheel of the engine comes in action for the third stroke of the engine. So the starter job of the starter is just to start the engine, and then the starter operation is removed. So starter is not connected to the engine throughout the engine operation. No, because if starter motor is on, as long as the engine is on, so engine will uh, give a power backward, and it will start driving the starter motor, and that will be a disaster for starter motor. So that does not happen. So what happens is, initially we just put a starter key, and that is also actually aligned with the ignition. So the starter key is started. That actually helps. There is a solenoid coil, so that get charged. That actually gives a huge current flow through the starter motor. Now we have seen starter motor is mainly DC series type. We will see today that DC compound motor also can be used as a starter motor for very heavy vehicle. So in that case, the starter action happens in two stages. But for small vehicles, four-wheelers, starter motor is a DC series motor. So starter motor is started through flywheel. So this, the pinion of the starter is aligned with the pinion of flywheel of the engine. So main job is just to start the engine, and then the starter motor is removed and is disengages itself and stops. So this is the process. So there are a lot of things to learn in that. So this is mainly our topic. So condition at starting, we had seen last day there are 8 conditions, and there are 4 more conditions which were discussed for starting of the engine or starting of the motor. And series motor and its characteristics. So we have seen that DC shunt motor is having a constant characteristics, constant speed characteristic. It is not used for starter. DC series motor has a very high initial torque, so that can be used for starting the starter or starting the engine. So mainly DC series motor, and today we will see that DC compound motor also may be used for starting heavy vehicles. So principles on construction of starter or starter motor, and working of different starter drive units. So mainly this third topic is what we are going to see today. First and second topics are done. That's what I have shown them in gray. Third and fourth topic we will be seeing today, and below this slide you can see this is a Honda starter motor. The starter is an isolated component within the vehicle electrical system. So battery is of prime importance, because as soon as the starter is connected, so here you can find there is a solenoid. So this solenoid is actually activated by the start key. So as soon as you are switching on the start key, so there is a coil inside the solenoid which gets energized, that moves the plunger, and that connects the very heavy current from battery with the starter motor. So all the circuits we will see today. So the starter motor is inside this, and here is the pinion, and it actually attaches itself with the flywheel which is connected here, and engine is towards the right side. So this is the motor, and this motor is a very heavy duty motor because it acts for a very small amount of time. So for very small amount of time it will act, it will create a rotation of this. This is connected to the flywheel to the engine. It will start the engine and disengage itself. So when the engine starts, engine runs. At that time the starter is not running. So its job is very temporary, and it's having a impulse kind of response. So what characteristic actually the starter is following, I have shown you yesterday, last day. So A and B are the characteristic which is for the starter torque. So we have seen as temperature is more, in that case the starter torque is actually higher. Okay, produced starter torque is higher. For very less temperature, minus 20 degrees centigrade, which is the limiting temperature, we find generally the starter torque produced by the system is very low. So here for very less minus 20 degrees centigrade, starter has to give more power. So here plus 20, engine is automatically, or the system is automatically producing more power for starting the engine. But here at minus 20 degree, there is a limiting temperature. System is producing less power to start the engine. So that's why in the cold, many a times, if the battery is not fully charged, the starter system will not be able to start the engine. Okay. So here is the main challenge. There is a limiting condition. So there is comparison between graph A and B for the starting torque. And then for the cranking speed, you can find out if temperature is more. Okay, in that case, this is a graph dashed line. So if temperature is more, in that case, we are finding is we are actually for less temperature, we are requiring higher amount of torque. So there is a requirement actually to achieve certain speed. So just say it's the speed of 100, we are finding that somewhere here we are. So around 200 Newton meter torque we require to create that cranking speed. But the same thing at plus 20 degrees centigrade, we require almost 100 Newton meter torque to create that cranking speed. So this C and D graph, they are actually comparison of production of cranking speed at lower temperature and higher temperature. So at lower temperature, what we are finding is to produce that cranking speed, we are requiring higher amount of torque. And for higher temperature, to create that same cranking speed, we require lower amount of torque. So always the higher temperature is preferred for starting. But in a very cold area, we have to start the four-wheeler there also. So the starter plays a very crucial role in that. So initially, whatever thrust is required to start the engine, so that comes from the starter motor. But who is supplying that energy? That supply energy is supplied from battery itself. But that battery energy is getting modified in the form of a very high kick initially by the starter motor. So this is a funda you have to understand. All the energy comes from battery. So heavy discharge happens in case of very cold temperature, and starter is just the actuator, starter motor. So through that, the battery power is converted to a very high initial thrust, and the flywheel is rotated, engine is rotated initially for rotation, and engine starts. And after that, starter is disengaging itself. So as a very general rule guide, the stalled torque means locked or stopped starter torque. It's required per liter of engine capacity. So bigger is the engine, liter is a volume. So liter means here the engine volume is talked about. So required per liter of engine capacity at the starting limit temperature is as shown below. So if it's a two-cylinder engine, so engines are of different capacities. Two-cylinder engine for maybe bike and all. So we are requiring 12.5 Newton meter torque per liter. Okay. As engine cylinder numbers are increasing, at that time we are requiring less torque per liter. Okay. Because here there are 12 engine cylinders. Each cylinder is producing 5.5 Newton meters. So you multiply them, that will be the total starting torque produced. So this is actually the torque produced per cylinder by the engine. So we are finding that a greater torque is required for engines with a lower number of cylinders due to the greater piston displacement per cylinder. This will determine the peak torque values. So how much is the peak torque required for every engine that we can find from here? And just to give you a figurative value, exactly how much is the torque produced per cylinder, that this chart is given. And this also we have seen last day. So the first one here we find this is a motor, starter motor. So this is, there is a winding in the armature. So these motors are following the Fleming's left hand rule. So there should be two inputs. The first input should be the input of electric current. Through this brush arrangement, it is connected to the armature. So this is armature, there is armature winding here, and there is a field winding. This field winding is actually creating the electromagnet. That is the job of this field winding. And the armature is the current carrying conductor. So Fleming's left hand rule says that if a current carrying conductor, that is the armature conductors, is placed in a electromagnetic field. So that electromagnetic is created by this series field winding. So current carrying conductor placed in an electric field experiences a mechanical force. So the shaft of this motor will move. So this is the motor principle. Now in the series bound motor, what we are finding is the field coil and the armature coil, they are in series. So that's why huge initial starting torque is produced. You can see here, this is the very high starting torque at low speed. So you'll be finding, so speed is very high at low torque. But the graph otherwise, there's a TIA graph. So when IA is even initially, a very huge amount of torque is produced. Okay. Second is shunt bound. So you are finding that this is a curve. So this is almost flat shunt motor. That means this is not used for starting, because for starting we require initially huge amount of torque has to be produced by the motor. Okay. And last one is compound DC motor for combined features of series and shunt. So this are having two things. So this is called as a field winding, as we found in case of series, and there is an extra another winding. This is called series field winding. This shunt field winding, this is actually for producing the electromagnet, and there's a series field winding which is actually in series with the armature. The extra winding here. So if the shunt field winding is connected across, so see this circuit. So if the shunt field winding is connected across the series combination of series field winding and armature, then it is called long shunt. And if the shunt field winding is connected only across the armature, then it is called the short shunt. Okay, so there are two connections here. One is this shunt field winding is connected here in the first case, okay, across the series combination of series field winding and armature. So this is the first case which is shown by solid lines. This is called as long shunt. And in second case, when this connection is taken off from here and connected here. So in this case, the shunt field winding is connected only across the armature. So whatever is the current, this is first given directly. Whole current is given to the series field winding. So in this case, the series field winding current is actually increasing. Initially, if you check, the shunt field winding is connected here. So whatever supply is coming from this side, that is getting divided into shunt field winding and series field winding. So initially there is a division of current. In short shunt, the division is happening here. So first the full current is coming to this series field winding, which is giving a high torque. And then after coming to this point, some part is going to the armature of the current and some part is going to the shunt field. So long shunt is actually having a distributed current, but short shunt is having the full current flowing through the series field winding. So there is a compound DC motor for combined features of series and shunt, and you can find compound motor is having very close characteristic to the series motor. So series motor is the best choice. So for four-wheelers, small cars, series motor is the best choice for starter motor. And for very big engines, that is bus, truck and all, where two-stage power transmission or starting happens. So in that case, we are actually using the compound motor. So here the examples are given. So whatever I have said, that field winding resistance, so there's a very important thing, that this field winding is having very lesser resistance in case of series motor, but the same field winding will be having higher resistance in case of shunt motor. So this is one thing you have to remember, that field winding resistance of series motor is very less, as it consists only a few turns of heavy wire. Heavy wire means thick cross section wire, which are having big cross section, means resistance is low. Okay. So in case of series DC motor, the series field winding and armature, they are in series. So whatever current comes here, so T is actually directly proportional to this I square. So here we find kind of a parabolic torque generated. Okay, so very high amount of initial torque is obtained due to the low resistance and no back EMF. Series motor gives high initial starting torque. This characteristics makes the series wound motor ideal for the starter motor. But you are finding here compound DC motor, series and shunt motor. This is actually using for very big machines. You can find here is the armature, which is producing the main rotation. So there is a series field and this is a shunt field. So in the first case, which I had shown in the previous slide, okay, so there are long shunt and there is short shunt. So in case of short shunt, the shunt field winding is connected only across armature, and series field winding is getting the full current from the input. But in case of long shunt, what we are finding is this shunt field winding is connected across series combination of series field and armature. It is said that depending on how the field windings are connected, the motor response varies. The shunt winding, which is generally having a high resistance in case of this kind of compound motors. So for series motor, shunt winding or field winding was having low resistance, but other motors, shunt and compound, the shunt winding is having high resistance. It may be connected either across the armature, so in this case figure B, which is called short shunt, or across the armature series field winding, here in the long shunt case. So now here is explained the starting mechanism. So large starter motors in case of truck and buses are often compound wound and are operated in two stages. At first, so this is the first stage, the shunt winding is connected in series with the armature. So in first case, this kind of shunt winding is connected directly in series with the armature. Okay, not in this case. So shunt and series, they are in series. So that is the first case. Shunt winding is connected in series with the armature. This generates low meshing torque due to high resistance of shunt winding. Later, a set of contacts are changed and it causes the main supply to be pushed through the series field winding only, and the armature is giving full torque. So second stage is this short shunt. So this long shunt is never used. So in the first case, this shunt and this series, they are connected in series. So it acts like a totally series motor in the first case, where shunt, series field, armature all are in series. In the next step, what is done is switches are changed so that the shunt field is connected across armature, and in that case, series field gets the full current. So in this case, a shunt winding is now connected in parallel with the armature. It will act to limit the max speed of the motor. So this more or less work like a shunt motor, which gives a constant speed. So this is the second part, or this is the part explained here, where the same compound motor can be used in two stages. In the first stage, series field and shunt field and armature all are in series. So the motor starts. And in the second case, the shunt field is connected across armature, so that the motor has already started. And in the second case, the motor will be running with a constant speed. Okay, so this is some important thing you just go through, that for big machines like trucks and buses, how is the connection of series field and shunt field winding, and how is the motor started. But mainly we are going to give importance to this, that is the top one, that is we are mainly going to use the series motor for the starting of the whole system. Now this is the most important slide. So this and two next. Okay, so this slide number 4, 5, 6 will be the slides from where actually the question will be asked. Okay, so this is actually, you can see, is the starter circuit. So left side you can see battery. This is actually a part of the starter circuit, but this battery is not a part of the starter. Starter, I have shown you a starter motor. Okay, so this is that starter motor. Okay, and this is the side of the pinion, and this part is actually goes towards the engine and flywheel. Actually this part is connected with the flywheel is connected to the engine that starts the engine. So now what happens, initially you can find out this end of the battery is grounded, this end of the battery is connected with two wires. Okay, this is the main wire. Okay, this is called as a light wire, the first one. Okay, this is the light wire, and this light wire is connected to the start key switch, and we can turn it initially to the right little bit, and the starts. So what happens, as soon as we turn this key to the right side little bit, the current flows from battery and it goes towards this solenoid. Okay, so this heavy metal, so this coil gets energized inside the solenoid, and as soon as this coil gets energized, so by that time, as soon as this gets energized, what happens is this thing comes down. Okay, or these two things are, these two metal plates are actually pulled up. So now this path is actually shorted. So directly current goes from battery through this solenoid to the motor. So these are the two things that happens initially. Again, I'll explain. So initially this part is open, because here you can see the solenoid is open, solenoid coil initially. Okay. So what happens initially, just the starter key is rotated small in the right side. What happens is battery current is passing through this light wire and going through the solenoid coil. So as soon as the current is flowing through the solenoid coil, this plate becomes magnetized. As soon as this plate becomes magnetized, these two metal things in both sides, they are taken up. So as soon as these two things are taken up, what happens is this contact, that is heavy wire contact, is established between the battery and the motor. So just to energize this solenoid, just to bring these two things up and make the connection between battery and starter motor, this start key switch is there. And as soon as this upper contact is made, by that time the start key is actually automatically it turns left, and there is no current flowing through this light wire. So light wire means thin wire is placed in the bottom, and heavy wire is placed in the top. So heavy wire is actually carrying the current from the battery to the starter. Okay, so first stage, just turn the key to the right, current flows through the coil, and this connection is established. And as soon as this connection is established, by the time this start key is off, that means no current flowing to the bottom part, all the currents are flowing to the top part through the heavy wire, and the starter motor is getting electricity. As soon as the starter motor is getting electricity with a very thrust, because it is a DC series motor, with a thrust it actually engages. So that engaging mechanism also having a lot to learn. I will be sharing a video with you, please check that. It's a 27 minutes video. You will understand what all many processes that happens during that engaging process, that is motor started and how it engages with the flywheel. There are a lot of things in between that, so you can find that in that video. Okay, so as soon as this motor starts, this pinion actually is engaged with the flywheel. The engine gets few rotations and engine started. And by that time, the starter motor is also coming to disengage state, and starter motor gets off. So when the engine starts, at that time, starter motor is no more rotating. Its job is just to give the initial thrust. So there's a starter circuit, which you can see here. Only main job is to operate this solenoid. And to operate this solenoid coil has to be energized, which is actually that energization contact is made by this starter key. And once the solenoid contact is made, the top heavy wire contact is made, and current flows through the starter motor. Starter motor starts, it starts the engine, and by that time, this starter motor disengages itself and it stops. So as long as the engine is running and all these things, there is no point of the starter. Initial part it has played and then it stops. So in comparison with most of the other circuits on the modern vehicle, the starter circuit is very simple. It's a two-wire parallel kind of a thing. I will show you the circuit in my next slide. The main target is to overcome the voltage drop in the main supply wire. So there are two paths we can find. This is the first path, and this is in parallel with this second path. Okay, so these wires are there. So the voltage drop in this wire should be as less as possible. That will increase the efficiency of the whole system. That will allow power waste. That will stop actually power wastage from the battery. Okay, so in these wires, the usage or the wastage of power should be as less as possible. So just go through. To make an engine start, initially it must be turned on at some speed. That means the starter should be turned on at some speed, so that the engine will in fact start the engine. So sorry, the starter motor will start the engine. So to make the engine start, initially the engine must be turned to some speed so that it sucks fuel and air into the cylinder and compresses it. Okay, so the compression stage it starts with. The powerful electric starter motor does the initial turning. So the starter motor is actually doing a turning kind of operation for the flywheel. Flywheel stores mechanical energy. It runs the engine. So its shaft carries a small pinion that is here. The shaft of the starter motor, it's actually carrying a small pinion, which is a gear wheel, and it engages with a large gear ring around the rim of the engine flywheel. Okay, so this pinion is attached with the engine flywheel. So in a front engine layout, the starter is mounted low down near the back of the engine. The starter needs a heavy electric current which it draws through the thick wires. So this up wire is the thick wire. Huge amount of current is flowing through it from the battery to the starter motor. So heavy electric current which it draws to the thick wire from the battery. No ordinary hand operated switch could switch it on. Okay, so that's why for switching the starter motor on, we need the help of a solenoid switch. So it needs a large switch to handle the high current. So this high current actually is handled by the solenoid based connection. The switch has to be turned on and off very quickly to avoid dangerous damaging sparking. So this switch has to be turned on. So it is turned on through the starter key switch. And when this starter is one to off, so this thing disengages and it is actually off, switching off the whole supply. So solenoid is used an arrangement where a small switch, that is the starter key switch, turns on an electromagnet to complete the circuit. Okay, so the starter has to be, the starter key switch has to be turned on and off very fast. So off automatically, on we have to do and leave it. It will come automatically to off because there is a spring loading is there. So this starter key is actually spring loaded. You can only load it in one direction, leave it, it will come back to its own position. So you can check the circuit which was shown in the previous slide. So these are the two wires. So this wire which is shown in the left side to the starter key switch, this is the below wire in the upper diagram. So there's a starter key switch, this light wire, current wire. So less amount of current is flowing through it and going inside the solenoid. And after this current is going inside the solenoid gets activated. And solenoid gets activated means the contact is made. So contact is made means in that case the battery through heavy wire. So the top wire is heavy wire. Heavy current is flowing through the solenoid switch to the starter motor. And starter motor started, and starter motor is actually connected. So this is the pinion here. It is connected to the engine and the flywheel. So there are two steps which we are supposed to do. First step, starter key has to be rotated right. As soon as it rotated right, this coil of the solenoid is getting electricity. It is actually allowing this T kind of a thing inside this to become electromagneted. It is attracting this two plunger from the both sides. It comes up. As soon as it comes up, it makes a contact with the heavy wire. So heavy wire is at the top. So from the battery, heavy wire is extracting huge amount of current in very short time. That is flowing through the starter motor, and starter motor starts. So the starter is usually operated by a spring-loaded starter key switch, that is this below one, or that is this one written in pink you can see, which is connected to the light current wire. So spring-loaded starter key switch, and the same switch also controls the ignition and supply to the other accessories as well. The supply from the key switch via relay in many cases causes the starter solenoid to operate. Okay, the same thing I am repeating. So starter key switch is connected, solenoid is getting current, solenoid is getting allows heavy current through the starter motor. So in some cases, so it's a special case, an extra other terminal on the starter solenoid is provided for output cranking, which is usually used for bypass and dropping resistor in ignition or fuel pump circuit. So this third point is not very directly important towards the starting. So this is talking about a extra terminal which may be used to bypass the dropping resistor on ignition or fuel pumps. This fourth detail is very important. So the starter requires high current. Starter means starter motor. Under adverse starting condition. So cold is a very adverse starting condition, minus 20 degree. So during adverse starting condition, the problem of voltage drop in main supply circuit, it becomes very significant. Okay. Maximum voltage drop of 0.5 volt is allowed between the battery and the starter when operating. So between the battery and the starter, there are two wires. So these two wires and this solenoid, they are connected in parallel. So this is the circuit where the power drop should be as less as possible. There is a solenoid and the wire. We cannot avoid solenoid, and power drop in solenoid is not much, but power drop in wires should be as less as possible, maximum 0.5 degree, not more than that. So to say it, very important thing. So I had to underline it actually. That is how much maximum voltage drop is allowed between the battery and the starter. It is saying it is 0.5 volt, not more than that. When the supply voltage is plus 12 volt. So this battery actually is plus 12 volt battery. So this is a worst case situation, and lower resistance value are used in most application. That means this wire should be very good conductors with very less resistance. Every wire is having a resistance. So this wire should be having very less resistance. So the choice of suitable conductors is therefore very important. So what are the conductors used for designing of these wires? it's a very big deal. Okay, so we have to uh, design these wires properly, starting from material to the length to its power drop. All this thing has to be designed very properly because not more than 0.5 volt drop is accepted here. Now the same thing, so whatever is there inside this, so the whole system, not the battery, apart from the battery, the other systems you can see find within the starter. So there's a cut section below, you can find here, this is the motor, okay, and above top is the solenoid, and this solenoid is getting supply through this starter key switch which is given here. So another bigger diagram I'll be showing you here, and this part is the pinion, and from here it comes out or goes in. So please check the video whose link I'll be sharing, and this part actually engages. So this is the output from the starter motor. This part actually engages with the flywheel. So flywheel is kept at the left, and whenever this motor rotates with very high torque, okay, this flywheel also will be rotated by this starter. That is the job. So top part, this top part is the solenoid coil, and bottom part it is the motor. So you can say this is a rotor part, and stator was there. Actually the stator has got cut, and there are a lot of other inputs from this side, all these things are there. So there's the front side, there's a pinion, and this part actually goes outside, so it goes out and comes in. This part is actually ejected, and it actually makes contact with the flywheel. So I'll just go through this, the most important part for operation. That's why I have just shown it by different colors. You can go through and you'll understand what all I have said in the previous two slides. Same explanation is given here as well. So the starter switch is usually worked by the ignition key. That is the key starter switch. Turn the key beyond the ignition on position to feed the current to the solenoid. So solenoid means this one. So the low current path is used in that case. The ignition switch has a return spring. Okay, that means this key has a return spring, so that as soon as we release the key, it springs back and turn the starter switch off. By that time, this plunger is moved, and heavy amount of electricity is passing through the starter. So when the switch feeds current to the solenoid, the electromagnetic pulls the iron rod in the solenoid down. Okay, so this contact is made. So up and down, don't worry. So this contact is made, and it closes the two heavy contacts and completing the circuit from the battery to the starter. That is, this top wire connection is made. So the rod also has a return spring. Okay, so here you can see that return spring like here. Okay, so when the ignition switch stops feeding current to the solenoid, the contact open and the starter motor automatically stops. So the most important line in this, so this rod, whichever rod is moving inside the solenoid, you can see the video and the show exactly how there is a piston which moves inside the solenoid coil. So the rod also has a return spring. So when the ignition switch stops feeding the current to the solenoid, the contact opens and the starter motor stops. So it stops automatically. So the return spring are needed because the starter motor must not turn more than it has to in the order of start the engine. So I told it initially that the starter is not running throughout the operation. The starter is running only to rotate the engine initially, and once it has rotated the engine initially, then the starter motor must stop. The reason is partly that the starter uses a lot of electricity which quickly runs down the battery. So as long as this motor is on, it will extract energy from the battery very heavily. Okay, that's why just after doing the job, starter motor should be turned off. It must not be on for a longer period of time. So that operation is kind of an impulse operation. Starter motor itself has a device called Bendix gear, which engages its pinion with the gear ring on the flywheel only while the starter is turning on the engine. So Bendix gear is connected somewhere here or here. Okay, you can find it out. So it disengages as soon as the engine picks up the speed. So initially engine was stalled. As soon as the starter motor rotates, it through flywheel engine picks up the speed, and automatically the Bendix gear disengages. As soon as that gear disengages, what happens is the starter motor is kind of stopped and it is not receiving any power back from the engine. So engine should never run the starter motor. the result will be disastrous. So whenever we are running a cycle, so we through pedal we are actually giving power on the wheels. So wheels should not give power back to our leg. Okay, that will give a reverse thrust. That should not happen. So starter should always give the thrust on the engine. Engine should never run back the starter. So as soon as the engine picks up the speed, there are two ways by which it does so. The inertia actually system. So inertia system disengages the starter from the actual engine. So this is the a very important part of the slide. You can check. So here you can find this diagram at page number 239, figure number 7.10 Denton. So this kind of starter. So the right side, this starter is actually Bosch starter, and there's a cut section of the starter and there's an open section. So every part is explained what is what. So this is the small part of the motor, point number 6. Point number 5 is the solenoid. So every part is explained. So here that gear mechanism is there in front. So point number 2, it's a pinion and overrun clutch drive. Okay, this one. And there's a casing. Number seven is yoke pole and field winding. Okay, likewise. And number 6, this is very important. This is armature with commutator testing for short circuit. So what all tests and other things are carried out for every part of a starter. Okay, so if you just put everything together, it will look like this, whatever is shown below. And just see what are the jobs of every point. So Denton, page number 239, you can find this. And there's another diagram of a starter. So this is more like a 3D diagram you can find. So this is the return spring. Okay, and there's a solenoid. So connections are given here. Solenoids are having 2 connection given from here. So this coming from the switch, that is starting key switch. This is the DC series motor which is running. So these are the armature coils, how it is connected. And this is the stator. Rotor is there inside, so rotor is connected. So there is a pinion, so that Bendix gear is here somewhere. So this part actually comes out. So when you see that video, whose link I'm going to see, it's a YouTube video, very properly they have shown all the functions of this solenoid and function of this gear, how it comes out, how it goes in, how it engages. So this pinion actually engages with the flywheel, and very sharply it does not go and engage. So thoda wobble and all, after a little bit wobbling and all, this pinion gets engaged with the flywheel, and it takes some time. Okay, so that meshing takes some time. Take some time means not minutes or so. Okay, within very small, maybe a little bit microsecond or 1-2 seconds, that engage happens. Okay, so you look at the video, you'll understand. So the pinion is moved by the solenoid. So here the pinion is there, it is moved by the solenoid. So there's the solenoid, actually it runs the connects the supply to the motor rotates, and the pinion gets rotated. Okay, so there is an initial period in which the motor turns slowly, so very slowly, to allow the engagement of this pinion with the flywheel gear. So the whole operation is more gentle and causes less wear of the teeth. So these are the teeth and the teeth of the flywheel, how they engage. So that you will find in that video. So here are many other parts of the same thing. So this is actually a pre-engaged starter. So this is a Bosch pre-engaged starter which is shown. Okay. So it says that pre-engaged starter. So this is the first type of starter we are going to see, most widely used. So pre-engaged starters are fitted to the majority of the vehicle in use today. So this type of starter provides a positive engagement with the ring gear. Okay, as full power is not applied until the pinion fully is in mesh. That means pinion is not fully connected with the flywheel. They prevent premature ejection as the pinion is held into the mesh by action of the solenoid. So initially the pinion and mesh, they are connected loosely, and as time goes by, after a certain time, some adjustments, they are actually heavily meshed with the flywheel. So a one-way clutch is incorporated into the pinion to prevent the starter motor driven by the engine. So this clutch actually disengages the engine from the starter when the engine has picked up speed. So very important, one-way clutch is incorporated into the pinion to prevent the starter motor being driven by the engine. So the starter motor should not be driven back by the engine. Engine should be initially driven by the starter. That is the condition. So Bosch pre-engaged starter is shown in the figure right side. During engagement, That means initially when the pinion is getting engaged with the flywheel gear, if the teeth of the pinion hit the teeth of the flywheel, so it happens not exactly the teeth goes into the slot of the pinion gear. So there is teeth slot, likewise it goes. So initially it may happen that teeth of pinion is hitting the teeth of flywheel gear. Okay, it should not happen. So if the teeth of the pinion hit the teeth of the flywheel, tooth to tooth abutment, the main contacts are allowed to close due to the engagement spring being compressed. So this allows the motor to rotate a little bit under power and the spin will slip into mesh. So this you will not understand. So there happens a little bit of rotation of the pinion thing, and if teeth and teeth was hitting initially, little bit adjustment of the pinion, and it will perfectly mesh with the gear of the flywheel. So to understand this, you have to see the video. These are not for exam questions, but just for your understanding, you have to see to the video. So this was the first type of starter, which is called as a pre-engaged starter. So what all starter we are talking about in slides 6, 7, 8, 9, 10, 8, 9, all are pre-engaged starter, which are used mainly initially. Now there's a second one, there's an inertia starter. So in all standard motor vehicle application, it is necessary to connect the starter to the engine ring gear only during the starting phase. So very important line is given at the top. If the connection remain permanent, that means if the starter does not get disengaged, what happens? The excessive speed at which the engine would drive the starter motor would destroy the starter motor immediately, because engine runs with far more greater speed. Okay, but starter motor runs with far more greater torque. So these are the two things you have to understand. Torque in starter motor is very high, but engine rotates with a higher speed. So if the disengagement of starter motor does not happen, in that case, the engine would be driving the starter back and the starter motor will get destroyed automatically because engine is rotating with a very high speed. Okay, so this line is very important. If the connection remained permanent, excessive speed at which the engine would drive the starter motor would destroy that starter motor immediately. Inertia type of starter, which is shown here, which was being used for last 80 years, okay, is now becoming redundant. So it is now becoming obsolete. It is 4-pole, 4-brush machine and was used on small to medium sized petrol engine vehicles. It is capable of producing 9.6 Newton meter torque with current drawn 350 ampere. So just imagine how much load it is creating on the battery. So 350 ampere. What I told was it's a 44 ampere hour battery. Over 20 hours, it is giving 2.2 ampere. So 44 ampere hour battery, you are asking the current of 350 ampere in a surge. So just imagine the amount of pressure you are creating on the battery. So the fields are wave bound. So in wave bound, P is equal to 2, and in lap bound, L is equal to P, and are earthed to the starter yoke. So yoke acts as a ground connection for the starter. The starter engages with the flywheel ring gear by means of a small pinion. It is in every case it is like that. The toothed pinion and a sleeve splined on the armature shaft are threaded such that when the starter is operated, the armature will cause the starter sleeve to rotate inside the pinion. So it happens in every case. So there are mainly two problems. First problem is the inertia starter is actually very aggressive in nature in engagement. That means with very heavy force and pressure, it actually get engaged with the uh, uh, flywheel, okay, gear. So this tends to cause the pinion and ring gear to wear permanently. So there is a lot of chance that when the combination or meshing is very aggressive, there's a big chance that wear and tear occurs in case of the teeth of the gear. Second problem is pinion is also prone to seizure often due to the contamination by dust from the clutch. Okay, so this was often compounded by application of oil to the pinion mechanism, which tended to attract even more dust and thus prevent engagement. So one very important thing we have to understand, that is this is the pinion and thing. So here there should not be any accumulation of dust or oil or grease. Okay, minimum amount of oil or grease, whatever is required, have to be used here. But if we are because this in case of inertia starter, it actually get engages with a very high amount of force. okay, aggressively. So any kind of dust particle, any kind of more oil and other thing, and that engagement will be disastrous. Okay, so that should be avoided. And there's a third type of permanent magnet starter. So inside this motor, instead of an electromagnet, so there are two coils I had shown in case of DC series motor. One is the field coil or shunt coil. It is called field coil. Another is the armature coil. So armature coil is nothing but the rotating part. Field coil is there to create the electromagnet inside the motor. But in this case, we are using permanent magnet. So we are totally cutting off that field coil winding. So it is making the starter a lot lighter, because the field coil itself is not there, because job of field coil is to produce the electromagnet. But as we are putting permanent magnet here, there is no need to put the electromagnet coil. So permanent magnet starters started appearing in the vehicle in 80s, 1980s. To main advantage of this motor compared with the conventional type, that is pre-engaged starter, are less weight and smaller size. It happens because we are cutting the field coil. This makes a PM starter popular choice due to the lower lines of today's car. Less space is now available in the engine electrical system. So now there's a very small cars are being designed. Reduction in weight provides a contribution toward the reducing fuel consumption. It's so as we are making the weight of the starter reduced, this is actually increasing the fuel efficiency. Its operation is similar to the pre-engaged type of starter, main difference being the replacement of field winding and pole shoes. Okay, so pole shoes is something through which the north-south pole, that electromagnetic flux that is actually passing through the rotor conductor. So there are two pole shoes, and in between pole shoes the armature is kept. So as we are using only permanent magnet, the pole shoes size becomes very small, and windings are not there. So this is the main difference. That is, windings are not there, pole shoes are not there. But in this case, higher quality of pole shoes of lesser weight is being used. So different material is used. So this reduction in weight is in the region of 15%, and the diameter of the yoke can be reduced by a smaller factor. Permanent magnet provides constant excitation. So speed and torque characteristic of this type of starter motor is actually giving a little less torque. Okay, so for smaller car, this is very properly suitable because size of this thing is less, and this is producing comparatively lesser torque. Okay, so battery efficiency again will be more. Due to fall in battery voltage under load, less armature resistance and interpole used between the main magnets, seldom it behaves like a series wound compound motors. So more than a series DC motor, it mainly behaves like a compound motor. So these are electronic starter controls. So there is something called as electronic control unit, ECU. So the electronic starter incorporates a static relay on the circuit board integrated into a solenoid switch. We have seen that. This will prevent cranking when the engine is running. Okay. So whenever engine is running, the starter is off action. It is not doing any action. So starter control can be supported by the ECU, that is the electronic control unit, that is the main brain of the whole system. And smart features can be added to improve comfort, safety, and service life. So these are four controls. There is a thermal protection, electrical protection, modulating the solenoid current, allowing redesigning of mechanical parts, allowing software operation, and other things. But main thing is this: the starter torque can be evaluated in real time to tell the precise instant of engine start. So first we put the start key switch. It is connected to the ignition. Ignition we will see in the next day. Then it starts with the it actually energizes the solenoid. Solenoid allows the current flow to the starter motor. Starter motor starts. It engages the pinion with the gear of the flywheel, and the engine starts. Okay, so starter torque can be evaluated in real time. So how much torque the starter is creating, and exactly when the engine is getting start. All this thing can be found out from the starter side. So the starter can be simultaneously shut off to the reduce wear and noise generated by the freewheel phase. So this is the starter installation, how to do the installation of the starter. So the main thing, so this is the starter, you can say this is the pinion and gear arrangement, and this left side, this is the actually big flywheel. And these are the gears of the flywheel. So this pinion is getting engaged with this gear of the flywheel. And this flywheel is actually connected to the engine. So this part, this is the flange mounted starter, it is shown. So starter is generally mounted in a horizontal position next to the engine crankshaft crankcase, with the driver pinion in the position for meshing with the flywheel or drive plate ring gear. So this is the so this is just for reading. Don't worry, this will not be asked in the exam. Just to show you how the starter installation occurs, how it engages. This is diagram is shown, and you can see there are three videos. Sorry, three links I am posting here. So with this PPT, I'll be posting. So previously also all the 8 lecture PPT and YouTube video link are posted already in your Google Classroom. Please check that. And the last video, so this is the link. I am just putting it to your sorry, I'm just putting it to your chat box. Please copy this link and view this at once. Okay, so I have posted the link. Please copy this link from your chat box, and I'll be posting all this to the Google Classroom as well. So this is a must watch link for the control of the starter and exactly how the car starts, and also very amazing amount of kind of videos are given in this second link. So please go through. So don't watch too much initially. Let me complete all the things one by one, and then you can see all the videos in this site. So there are a lot of good videos available on YouTube on starting of the any vehicle and on starters. So please go through.